have a look at this triangle here. Let's say this is a right angle triangle, and this is 1, and this is also 1. It could be 1 centimeter or it could be 1 meter. It doesn't matter. It will still work. It would even work if it's 1 kilometer. Now, if you add up all the angles inside a triangle, it doesn't matter what triangle. If you add up all the angles, it should come to 180 degrees. Okay, so I know that if I add up all the angles here, this is 90. If I add up all the angles here, it should come up to 180. Well, if this length here is exactly the same length as this one here, then I know that this angle here must be exactly the same as this angle here. Well, this angle here must be 45, and this is also 45. Because if you think about it, if you add up all the angles, it must come up to 180 degrees. Well, this is already 90. So if you take 180, get 180, take away this angle here. So what's left will be 90. Well, 90 divided by 2 must be 45. So this angle here must be 45. It can't be anything else. Well, if this is 90, this cannot be, let's say, 30. Because look at this here. I know that all the angles added together inside a triangle must come up to 180. Well, this cannot be 30, and this cannot be 30 because 90 plus 30 here, 30 here, plus 60 here equals 150. So this cannot be 30. It has to be 45. It has to be 45 because if you look at this here, hang on. This here is 90. Look, 90 plus 45 and 45 is 90. So if you add up all the angles here, it comes to 180 basically. So when you're told that this length here is the same as this length here, then you must know that this is 45 degrees. Okay, it's because you know that this angle here is the same as this angle here. So this here we know is 45 degrees. Okay, hang on, bear with me. Now look at this length here. This length here is actually we can use Pythagoras to work out this length here. Okay, so hang on. If this is 1, this is 1, and this is a right angle triangle. Well, Pythagoras is saying, let's call this x. X squared equals 1 squared plus 1 squared. Okay, hang on, bear with me. So 1 squared, 1 times 1 is 1, and over here will also be 1. So now add the 2 together, so it will be 2. X squared equals 2. So we know that this length here is root 2. Okay. This length here is the square root of 2. Okay, hang on. Let me clear this up. Hang on. So if this is 1, this is also 1. And then this length here must be square root of 2. And we know that this angle here is 45. Okay, this is also 45 degrees. Now look at this here. So hang on, let me get rid of this to tidy up. So look at this here. Hang on. So if you cos 45, okay, if you cosine 45, remember cosine is like the cord jumping out of the water. That equals 1 over root 2. Now, if you don't believe me, if you cosine 45 on your calculator, whatever the answer is, it should be the same as 1 divided by square root of 2. Remember, this bit here, you've got to square root of 2 first, and then get 1 divided by the square root of 2. So if you don't believe me, you can actually punch into your calculator cosine 45. It will give you a number, and that number will be the same as 1 over root 2. So sometimes in maths, people use cosine. Whenever you see cos 45, you can actually replace it with 1 over root 2. Okay. Also, if you look at this, hang on, let's see. The sun is here. The sea is here. Bear with me. You know, this here is sin, isn't it? And this here, well, sine, sorry, sine, and this here would be sun rays shining down, giving you a sun tan. So this would be tan. Well, you can use the same thing here. If you tan 45, let's say tan 45, this equals well, tan is this one here. It equals 1 over, and then you hit the 1 here. It would be 1 over 1. So that's just 1. So if you tan 45 on your calculator, it will give you a number. Well, that number will be the same as this number here, 1. So sometimes in math, if you see tan 45, you can actually replace it with the number 1. Okay, and also what's the other one? We've done cos, sine. So the other one is sine. Now, if you look at this, sine 45, that equals, well, it starts here 1, and then divided by root 2. So if you ever see sine 45, you can actually replace it with this as well. Actually, if you look at the cos earlier, cos 45, that's the same, isn't it? Look, cos 45 is 1 over root 2. So well, when you see sine 45, you can actually replace it with this, root this, and you can actually replace it with, well, that's the same as cos 45. Well, if you don't believe me, just check it on your calculator. Punch in sine 45, and that should be the same as 1 divided by this number here, root 2. Okay.